Okay, so today we're going to be working with geometric series. Our geometric series is a geometric sequence, but we are adding every single term, right? So as you can see right here, this is a geometric series, right? How can I find it? So I'm going to divide the second one divided by the first one. Then that's -2. The third one divided by the second one, that's -2. The fourth one divided by the third one, that's -2, and so on. So as you can see, in this case, my ratio is -2. Now, there's two type of geometric series, the finite series and the infinite series, geometric series, right? It all depends on the R. If the absolute value of R, if the absolute value of R is greater than 1, that means that is a finite geometric series. And we are using the equation S sub n, the sum of the n terms, times a sub 1 times 1 minus r to the n divided by 1 minus r, right? So as you can see, I don't even need the last one, but I do need to find my last n because I need that n right here, right? So this exercise, again, my formula I'm going to use, this is the finite series and the geometric sequence as a sub n equals a1 times r n minus 1. So I need to find that n right here. So in this case, this is 512. So that means that I need to substitute. So I have 512 equals 2 times -2 times n minus 1, right? So in this case, I'm going to start by dividing by 2. That's 256 equals -2 times n minus 1. So I need to equal all to have the same base. So 256 is the same as -2 to the 8 equals -2 to n minus. And now that I have the same base, I just can equal the exponent. So n minus 1, so n equals 9. So now I'm going to go to my series formula right here, and I'm going to plug in the information. So S sub 9 equals, the first term is 2 times 1 minus r, but r in this case is -2 to the 9th divided by 1 minus -2. So this is 2 times 1 minus -512 divided by 3, right? So 2 times negative, this becomes positive, so 513 divided by 3. Okay, so this is the same as 342. So that means that the sum of this geometric series, sorry, is 342. Okay, my next one. Again, I'm going to check that if it's geometric. So I'm going to divide -6 divided by 9. The second one divided by the first one. So this is -2/3. The third one divided by the second one. So this is -2/3. So the fourth one, a third divided by 4, right? So this is -2/3. And the last one, 16/9 divided by -8, so over 3. So this is -2/3. So my ratio on this exercise is -2/3, right? So it doesn't matter in this case that my R is less than 1 because I have a finite series, because as you can see, it starts on one number and in it ends another number, right? Just in this case, you can just plug in that information in your calculator, but I'm still going to show you how, right? So in this case, I have x sub n equals the first term, 9 times 1 minus -2/3 to the, in this case is 1, 2, 3, 4, 5. So my n is 5. Let me substitute that 5 over here also. 5 divided by 1 minus negative 2/3, right? So I have 9 times 1 plus 32 over 243, right? Divided by 1 plus 2/3. So in this case, I'm going to find a common denominator. So I have 9 times 1 2 times 243 plus 32 divided by 243 divided by 3/3 plus 2/3. Right, so 9 times 275. So if I simplify this 9 with this 243, that becomes a 27. So I have, this is the same as 275 over 27 divided by 5 over 3. Right, so 275 over 27 times 3 over 5. So I can simplify, cross simplify. This is 55 and over 9, right? I'm simplifying here. This is 1, this is 9, this is 1, this is 55, right? So 55 divided by 9 is 6.111. That's it for this exercise. This one says a game show is offering a price of 1 cent on the first day, 3 cents on the second day, 9 cents on the third day. So what is the total amount of money earned from the prize in 2 weeks, right? So we have here days, then in weeks, so that means that I'm going to have n equals 14, right? Because there's 14 days in a week, in 2 weeks, right? Okay, so we have all the information that we need to plug it in on this equation. So S of 14 equals 1, because it's 1 times 1 minus 3 to the 14 divided by 1 minus 3, right? So I have 1 minus a number very big, 69 divided by negative 2. So 478, 68 divided by negative 2. So divided by negative 2, that's negative 1484, or positive, sorry, positive, right? Cents, right? So if we want to convert that, we're just moving. So 23914.84. Right, so in 2 weeks, the price is going to be 23,914 with 84 cents. 2 weeks. Right, so in this case, again, I have n to the 1 of 3 to the n. I'm going from 1 to the 4th. I know that is a geometric because I have 3 to the n. So that means that I'm going to substitute, right? 3 to 1 plus 3 squared plus 3 cubed plus 3 to the 4th. This is 3 plus 9 plus 27 plus 81. So it's 120. And that's it with that exercise, right? We can also find the last one and then just substitute that on the equation. Okay. So now I want to determine if geometric series diverge or converge, right? Diverge is that it's going to continue growing. So if R is greater than 1, it diverges. If the absolute value of R is less than 1, that means that converges to a same point. It's going to exactly the same number. So my first step is to find R. So in this case, I have 1 plus 1 over 4 plus 1 over 16 plus, and it continues, right? So if I divide 1 over 4 divided by 1, that's 1/4. If I divide 1/16 divided by 1/4, that's also 1/4. So as you can see here, my R is 1 over 4. So because my R is 1 over 4, that means that this converts to a same number, and this is an infinite series. So that means that I'm going to use my infinite series equation. A sub n equals a sub 1 divided by 1 minus R. That's only when it converts to a number. That's only when it converts to a number. So it's an infinite series. Okay. So this is the same as S equals 2. This formula does not need the n right there, right? 1 over 1 minus 1 over 4. So 1 over 1 over 4 minus 1 over 4. So this is 1 over 3/4. So when I do that division, this is the same as 4 over 3. So this is 1.333. That's it. Again, this is only when R is less than 1. If we have an infinite series and R is greater than 1, like on this one, right? As you can see, my R here is 2, right? Because I have 2 divided by 1 is 2. 4 divided by 2 is 2. So R here is 2, is greater than 1. So in this case, this series diverges. That means that it's going to continue growing that series, and we cannot find that number at the end.